All right, so now I want to turn to a couple of case examples to concretize what I've described fairly abstractly here as the process of human cognition, from its roots in observation with sense perception on through concept formation, the ability to form sentences, to narratives and theories. I want to use two examples, more extended examples, one from the history of science, one from the history of literature, to give a range of examples to show this method in practice here. First, I want to turn to the case of Ignaz Semmelweis. Semmelweis, one of the great heroes in the history of medicine, Hungarian-born, came to the University of Vienna Medical Hospital for his training and stayed on as a physician, Vienna then being one of the leading centers of medical research. Worked in the maternity wards as part of his duties there. In the maternity ward at the University of Vienna, actually there were two of them. There was a first division and a second division. Part of his job involved dealing with women who had just given birth recently. And in the course of his activities, kind of a hunch came to him, or a feeling that came to him, that there was something amiss in the first division, that women in the first division were dying much more frequently and at a higher rate than women who had recently given birth but who were housed in the second division there. Now, the point here is initially that Semmelweis, as a practicing medical doctor, is of course going around doing lots of observation, right? He has his patients, and so he examines them and he notices various sorts of things. He has a memory system, and so he's remembering various sorts of things, but he's not yet functioning necessarily as a scientist. He's not embarked in a process of trying to figure out new stuff or to solve a particular problem here. But nonetheless, an idea comes to him that maybe there is something that is worth investigating here. And what he then has to do is figure out and bring to his consciousness what the issue is. And so he has a sentence formation, something like the following, where he says, "It seems that women in the first division are dying at a higher rate than women in the second division." All right, and the symptoms, the women were dying and were puerperal fever, which was then a fairly common set of symptoms that had a high mortality rate, but it seemed to Semmelweis that more women in the first division were dying of that than in the second division there. Now, this is already some fairly sophisticated cognitive work that's going on, to be able to understand all of these concepts, to string them together in a meaningful sentence and to know what that means. We have a spatial division that's going on here, first division versus second division. We're talking about women who have recently given birth, women who have certain observable symptoms that we've classified as puerperal fever, and we have a fairly complicated mathematical concept here, a rate, right? A death rate, which is you take your population, the total population, the number who die, and you do a division operation there. So there's already a lot captured in the concept of a rate here. Now, at this point then, Semmelweis becomes not simply a practicing physician, but an investigator, a scientific investigator, because he wants to know, is this true? It's an initial hunch, or it's an initial feeling, or it's an initial impression or initial thought that came to his mind, but he doesn't yet know that it is true. All right, so the question then is this a true proposition or not? So what Semmelweis then does is he goes to the university's, the hospital's records, and he does some counting and some math. With fairly good records here, and he organizes the records in a way that's going to bear on the question that he has in mind here. So he has a question about the first division, and then there's the second division. I'll keep my thing parallel here. And he counts by time. I believe the first year was 1844. So here we have a spatial division. Here we have a time dimension. So we have space and time put into a classification scheme. All of the observational data then gets fit into that. In the first division, what was the population of women who were lodged there in 1844? There's a certain number there. He counts that up. what number of those women died of puerperal fever. We count that number up. We do the mathematics, and we have an X, right, a number that goes in here. We do the same thing for the second division. What was the population in the second division? What number of women in that second division died of puerperal fever? We do the mathematics, and we have another number here. Now, I'll check my records. For the year 1845, or 1844 rather, it turns out for the first division, the X equals 8.2%. That's the death rate. And for the second division, the death rate is 2.3%. All right, that looks like a significant difference bearing on the accuracy of his initial hunch that we have up here. We do the same for 1845. The number in this year turns out to be 6.8%. The number over here turns out to be 2.0%. Again, a significant difference. 1846 is a disaster year for the first division. This number jumps up to 11.4%. More than 1 out of 10 women is dying of puerperal fever in the first division, and in the second division, this number is 2.7%. All right, so what we then have is this sentence, which we can now treat as a hypothesis. Is this hypothesis true? Semmelweis's question is, how would I determine whether that hypothesis is true or not? And he has a methodology in place for being able to do so. It involves a classification scheme. It involves using a certain kinds of mathematical logic then to force the data to yield results that we want, right? Doing some theoretical investigation here and the tools of logic in that place, putting it into this classification scheme that then yields various results that bear on this particular situation. So what we then can say is what Semmelweis is doing is forming now a hypothesis. The women are dying at a higher rate in the first division than they are in the second division. If that hypothesis is true, then I can make a certain prediction. And the prediction is that the hospital records, when analyzed in a certain kind of way, will show that the death rate is in fact higher in the first division than in the second division. We're then in a position to analyze the results, and we can see, yes, consistently, the women are dying at a higher rate, a significantly higher rate in the first division compared to the second division. And so what we then have is the prediction that turns out to be true. So we make an inference, a logical inference, and that is that the hypothesis is confirmed. Right? We have data that supports positively our initial hypothesis. That was initially just a hunch here. Okay, now science kicks in for Semmelweis in a fairly serious way. If it is true that women are in fact dying in the first division at a much higher rate in the second division, this requires explanation, and so we want to figure out why it is true. So we're entering into new territory, uncharted territory, and Semmelweis then needs to use the full power of his cognitive abilities to try to figure out this important piece of knowledge here.